Hi, this is Lindsay Moeller, and this is my final presentation for CIT 260, Object-Oriented Programming. And the game that my partner and I created was the Santa Challenge, where the player would act as Santa, and the goal was for them to deliver all of the presents around the world in a certain amount of time. And in this presentation, I'll be reviewing static and non-static variables, arrays, array lists, and enums, navigating arrays using the for statement, and then I'll also review exception handling, character and byte streams, and how to write data to an external file. So here we go. So first step is static and non-static variables. Static variable is essentially a global variable, and this just means that it's associated with a class rather than objects of a class. So they're also called just plain class variables. When you want to define a variable independent of other objects of a class, that's when you would make it a static variable. And this just means that the variable can be accessed even before any of the objects of its class are created or before referencing any of those objects. Static variables get initialized or loaded when the instances of the class are loaded. So this is a screenshot from our main class, which was called the Santa Challenge, or just Santa Challenge. And you can see all the static variables because they're designated using the keyword static. And non-static variables are also referred to as instance variables because they're specific to an instance of a class that they're associated with. And instance variables are declared in either the class or method. They're created when a new object is created, and they're destroyed when that object is destroyed. And this screenshot, the first one on the left, is of our map model. And these variables here are the instance or the non-static variables. And you can see one was the variable location, so private location locations. So it's just a variable of locations, a location variable called locations, which we then, below that, we had a getter and setter function for it. So if, or rather when, we want to call those variables, we did that from our map control class, which is on the right. It just shows you how we accessed that. We had the two types, the object reference, which in this example was map, and then dot, and then the variable name. So arrays, array lists, and enums. We'll start with arrays. And an array is a collection of variables or objects of the same type, and it has a fixed length, so you can't add or subtract variables or objects from it once it's been declared. And this example from our game was, again, our map control, and in it we had an array of scenes, which really ended up being locations, so we kind of mislabeled that. But you can see on line 95 that we created a new instance of the array using the data type, the square bracket, and then the name of the variable. And in our example, we defined the number of elements or the number of items that we were going to declare in the array. That's why there's that number 25 there. And we'll actually come back to this example in a minute. So on to array lists. An array list is similar to an array, but the difference is that it isn't a fixed length. So it's a variable length, so you can add or subtract from it. So an array list is used when you have a list that, like I said, you want it to be a variable length, you want it to change, that you want to be able to add and subtract from. So we didn't end up using any array lists. We used arrays and enums. But one example that we could have implemented would be like, so we have an array of inventory items, and that's all the possible inventory there is, but we could have made an array list of characters inventory, so what they had collected, and it would grow or shrink as they either found or used an inventory item. And finally is the enum. So this is similar to an array and an array list. It's a fixed length like an array, but the objects can never be changed, so they're constant. So any So you would use an enum when you had a list that wouldn't change. So that's why we used it for our inventory, because the list of what the inventory was never going to change. Yeah, so that's enums. So then the for statement is next. And the for statement is used to move through an array or an array list. You might also hear it called a for loop. And the way that it works is by repeatedly executing a bit of code until a certain condition is reached. So the way that that works is that it sets a control variable that has a condition to test for, and then finally a counter that designates how to move through the array that's testing for the condition. So if the condition's true, the loop will continue to run, so it'll go through that code again. And if it's false, then that means the condition has been met and the loop will stop. It will exit out of it. So I had mentioned that we'd come back to this scene example, and here we are, because this is where we had a loop to loop through all of our scenes. So in this example, the int I equals 0, that I is the control variable, and we said as long as the I is less than the list of scenes, so scenes.length minus 1, that's the condition we're testing for. And this is just saying that as long as this condition is true, run this loop again. But as soon as it's no longer true, as soon as it returns false, then we're going to stop. So it's checking that I is less than the number of scenes, and then the minus 1 is added because if you know that I said that in our array of scenes, we declared that there was going to be 25 scenes, and because an array starts indexing at 0, that means there's really only 24 indexes. So my loop needed to stop at 24 and not 25. So that's the -1 or -1 there. And then the last part, the I++, that just determines how we will increment our counter. And it's just saying we'll increase it by 1 every time it loops through. Okay, so exception and error handling. An exception is an error that occurs in your program, and exception handling is just how your program is going to deal with that error. So, throwing an exception, how to throw errors. How do we avoid errors that occur, and how do we keep them from breaking our program? The answer to that is by throwing exceptions. So the code that you want to watch for exceptions, you would put in the try block, and if an exception occurs, then that block is thrown. And you can actually manually throw an exception by adding the throw statement. And so that's what we've done here is public static void continue game throws game control exceptions or exception. So catching errors is done using the try catch block of code. So after you try something, if it doesn't work, then you can catch it. So when an exception is thrown, it gets processed by the catch statement that corresponds with the exception thrown. And it's important to note that you can have more than one catch statement with your try, and it's the type of exception that ultimately determines which of the catch statements is going to get executed. It's also important to note that the catch statement can only run if the exception is thrown first. So you have to be sure you include that throw statement, that throwing exception. So in this example, we are throwing the game control exception, and then we're trying this input-output stream, which is just going to try to get and read a file path that a user has entered. And then if the program tries it and can't find it, then it will go to the catch statement, which will run, in this case, the file not found exception, and throw the game control exception message to the user. And like I said, so if we were to not catch this exception, then the default Java exception handler would catch it, and that would actually end up terminating the program. So to propagate errors, to propagate runtime errors, means that if there's an exception that's thrown and it isn't handled in that message, then the program will go up the calling hierarchy looking for where the error is handled with the try-catch statement. You can propagate up the calling hierarchy by adding the word throws to the functions in that hierarchy. So here is the start new game method in our main menu view, and in this try block, it's going to try to run the create new game method from the game control class. And then the next screenshot is the game control. This is the one on the right. The game control with the create new game method. And you'll notice each of the methods is throwing a map control exception. So any method called from the create new game method, like the move Santa to start, you'll see that it's also throwing the map control exception. So what happens if an exception happens in the move Santa to start method and we don't have a try catch block, then the exception will actually be handled by the start new game method, as it will be propagated up the calling hierarchy. So there's no try catch in the move Santa, so it'll go to the create new game where there also is not a try catch, so it will go up to the start new game, and that's where the try catch statement is. So that's where it will catch, and it will, yeah, like I said, go back to the start new game method, and that's where it will actually be handled, because that's where the try catch statement is. Okay, so real quick, character streams versus byte streams, and we'll actually start with byte stream, I think. The byte stream handles input and output, or the reading and writing of binary data to a file. And it does that using the input and output stream. And the byte stream works by writing or reading the data 1 byte at a time. So the byte stream reads data 1 byte at a time because it's ASCII based, and it can only be, because of that, because it does 1 byte at a time, it can only be used for Western languages. And but it can be used to write to a file. That's reading and writing to a file when a human doesn't need to read it. That's most commonly when it's used. And this is an example from our continued game method from our game control class. And we use the file input stream and then the .read object to read from a file. And a character stream is used for handling input and output of characters. And this really just makes it human readable. So Java's default for storing data is Unicode, which maps each character to 2 bytes of memory, as opposed to the byte, which, like I said, it's ASCII based, so it maps each character to a single byte. And a character stream uses the abstract classes reader and writer, and we use subclasses of those that are the buffered read and the print writer. Buffered reader and print writer. And we use those to input and output data to a file. So if you want to be able to view the data, you would want to use a character stream instead of a byte stream, so that it is human readable. And the first example, you can see we have the buffered reader to get input from the keyboard, and then the print writer to print to the screen. And you can see we used that console variable in this .console.println to print the directions to the screen for the user. So lastly, I'll show you how to write character data to an external file. So this is the game menu, and you can see if you choose option A that it will print a report of the inventory the player collected. And the way that works is that it's going to prompt the player for the file name where they'd like the report printed. And then the last screenshot is where it's actually generating the report, and it will print it to an external file that was specified to the user. So all that information will be printed to the user in a readable form. And then, unfortunately, we ran into an error with our main menu last week, and we kind of just ran out of time to try to fix it. So right now our start game doesn't work, but we do have access to the help menu and how to win and different locations, or choosing where to save your game. That writes to an external file. So even though it's not fully operational, this class and this project was a great learning experience, and we were able to see the tremendous possibilities of what Java does and what can be accomplished through Java programming. And that's it. Thanks for watching.